Hello, everyone. We present to you Vigilance X, your cybermate. We are Team CupNoodles, a bunch of passionate developers and sleepless coders who believe that just like instant noodles, good security should be quick, reliable, and accessible to everyone. So, without any further ado, let's hop onto the description. We are excited to take you into the lesser seen layer of the web, the world of embedded scripts, and show you how something as small as a script tag can lead to major cyber threats. With the rise in supply chain attacks, XSS injections, and third party dependency exploits, web security is no longer just about firewalls, it's about code hygiene. That's exactly where our tool VigilanceX comes in. Now, what it solves? At first, it detects vulnerable scripts in real time. Yes, it automatically identifies third party or inline scripts on websites that match known vulnerable or malicious signatures. Second, it mitigates supply chain attacks. It prevents exploitation from compromised external script dependency. For example, hijacked CDN scripts. Third, it supports informed decision making. Users as well as developers, they receive AI generated reports detailing potential threats and mitigation strategies. Fourth, it closes visibility gaps. It provides visibility into all loaded scripts, including those which is often overlooked by traditional scanners or browser tools. Fifth, educates users as well as developers. Yes, it's a one stop solution. It enhances awareness by explaining how a script may be exploited. For example, credential theft or key logging. Last but not the least, it reduces reliance on manual security scans. It integrates script security evaluation directly into the browsing experience.
So now let's come to the part how our proposed system works. So basically, the architecture is as follows. We have a script extraction module. The job of this module is to uh, extract all the inline as well as externally linked scripts from the web page as the user visits. The second module that we're using is the vulnerability matching engine. The extracted scripts, URL, and hashes are matched against the vulnerability database, including known hashes, domain, and suspicious pattern. Then comes the threat analysis integration using Gemini API. Now, identified suspicious scripts are sent to a secure Gemini API instance. Gemini performs the statistic analysis, payload recognition, and contain awareness threat reasoning. Result returns a detailed threat summary with the type of potential attack. For example, it could be DOM-based accesses or key logging, or and it also gives a summary of the severity rating and recommended suggestions. Now, next module is the user interface database. It displays the list of all the scripts, their sources, trust levels, and vulnerability status. It shows Gemini generated threat report in a collapsible panel with a very simplistic UI that the user may feel comfortable with. Next comes privacy and security layer. All the data is handled locally unless a script is flagged as suspicious. Gemini API only poses flagged content and operates under strict privacy rules. Now, coming to the demonstration part, this is our flowchart. Let's go to the demonstration. So let's start with a demonstration. To add an extension to Chrome in a developer mode, we need to first enable this option. Then we need to load the respective extension folder into Chrome. Let's click on load on pack. Then this is the extension folder that we will be using, and yeah, this is added to Chrome. So this is our extension. I'll just refresh it once. Uh, let's pin it for simplicity. Say I'm a user. I just want to visit. I'm visiting a new website for a new website. I need to be sure that my activity is absolutely safe over there. So as I visit the website, as you can see in the top right corner, our this is a malicious website uh, for testing purpose, and in the top right corner we can see we're getting some notices. So the AI analysis is generated by taking into account the vulnerabilities found by the extension, and they have been passed on to Gemini, and Gemini gives the response. So this is the response from Gemini. Now, what are these vulnerabilities basically? These are the tools with the respective version that has been used in building this website, and using certain kind of tools which are deprecated or which have been used since a long time. Basically, they can increase the risk of attacks, and accordingly, so the attacks associated with a particular tool and the version has been listed here. So you can see for this version, these are the possible high risk attacks and these are the possible medium risk attacks. And yeah, the attacks have been classified into high risk, medium risk, and low risk. Uh, if I click on, say, this is the kind of attack that can take place on Dozo 1.4.0. If I just click on this hyperlink, it will give me the description of the particular attack type. So this is the attack on Dozo, and this severity, as you can see, is high. Now, all this information about this risk is obtained from our database. This is the database that we're using. That particular versions and their associated data attacks and the risk has been listed over here. Now, say for example, uh, certain thing is not in our database, so we'll just search the internet, and if it's found it vulnerable, we just keep it unknown since we don't know it exactly. And if I just close this off, then this won't be visible. Okay. Now, for the convenience of the user, there are two kind of mode that we're using. One is a dark mode and one is a light mode. So yeah, yeah. The risk associated with a particular version has been, if it's marked with red, then it's highly risky. If it's marked with uh, yellow or orange, it's a medium risk. They are medium risk associated with it, and if it's marked with green, then it's low risk are associated with. Low risk is associated with it. So I'll just switch to dark mode again. And deep scan and scan are two features that we're using. Scan just follows the link till the first jump, while deep scan follows the link for multiple jumps and find the vulnerabilities. Okay. So the total vulnerability found here were 22, and total URL scanned till now 7. Now, say for example, I visit a safe website. I'll just go to, yeah. So since it's a safe page, there are zero vulnerabilities associated with it. Okay. So thank you. That's all. Let's get back to our presentation. Uh, Basically, there is a script extraction module. Then whatever I said, the data flows in a particular in this direction according to the flowchart. Now, coming to the next part is existing systems and drawbacks.
Let's begin with what already exists. We have browser extension plugins like NoScript and uBlock Origin. They do a good job blocking unwanted scripted, but they stop there only. They don't actually analyze the script's content or check for known vulnerabilities. Content security policy, which is also known as CSP headers, and browser-based security tools help reduce risk like XSS attacks, but their effectiveness heavily relies on developers configuring them correctly. And even then, they offer no direct alerts or insights to end users. Platforms like VirusTotal or Hybrid Analysis allow script scanning, but the process is manual and not integrated in the browser and lacks any form of intelligent threat analysis using AI or large language models. And this leads us to the core drawbacks. Right now, there is no browser extension that brings together real time script parsing, vulnerability mapping, and AI based threat assessment into a single seamless tool. Worse still, even when threats are detected, there's a lack of automated, understandable explanation for non-technical users, the very person who are most at risk. Clearly, there is a need for solution that doesn't just block threats but also explains them, maps them, and makes the web safer in real time. That's the direction we are proposing.
So uh, thanks for being with here, being with us here, and this is our team. Tanvi Tejashwani from VIT Mehta, me myself Sandeep Kumar Das from NIT Rourkela, and Mr. Ranjan Das from NIT Rourkela. Thank you.